Hello friends, this is Vimal. Today we will be discussing about the spherical mirrors. So concave and convex mirrors, we are going to discuss about them. So the rear view mirrors of your two-wheeler and car or the dentist mirror to identify the cavities comes under this category. Now we are going to see what happens. The first thing is the Cartesian sign conversion is important. So this exactly gives how the images are formed, whether which side you have to take it as positive, which side you have to take it as negative. So these things we'll be discussing it in detail. Because without this convention, we cannot identify the mirrors and the image formation in the mirrors. So the first one is how the images are formed in convex mirror and how the images are formed in the concave mirror. That is the representation. We are going to discuss them. So the first we are going to draw a surface. Since I am taking it as a concave surface, I am plating it on the outer side. That means in the case of mirrors, one side will be plated. So when you are plating the outer side of the mirror, we call it as the concave mirror. The midpoint of the mirror is represented as P, which is called as the pole of the mirror, focus or the focal length, and the center of curvature C, or twice the focal length. So this is how we are representing them. The line joining, especially the focus, center of curvature and pole, we call it as principal axis. So C, I represent it as center of curvature. The next one is P, I call it as pole. The next one is F, I call it as the focus. So the line which is joining the center of curvature, focus and pole, I call it as the principal axis. So it is called as the principal axis. So that forms the base of the mirror where we are going to draw the images. First, let us assume that the incident ray direction is from left to right. So in most of the cases, we consider this as primary. So always the incident ray direction will be from left to right. So that's what we are drawn. If we are following along the direction of the incident ray, we will be taking the sign as positive. And if you are following opposite to the sign of the direction of the incident ray, we will take it as negative. So this thing you have to keep into mind, and this point is very important. That's why I'm writing it separately. So all the distances are always measured. So all the distances are measured only from the pole of the mirror. So this thing you should be very careful. Always all the distances are measured only from the pole. So this you have to keep it in your mind very clearly. So upright in the plus y axis, that is upright position, we take it as positive, and in the perpendicular to the downward position, that is minus y axis, we take it as negative. So that will be the easiest representation. At the end of this particular video, I will be showing how to mark it. It will be very easy. So I am representing it in the form of axis just for your reference. So if you take it along that center origin, along the right, we call it as positive, plus x axis. So vertically upwards plus y axis, vertically downwards minus y axis, and left hand side we call it as minus x. So now we are representing the arrow mark. See, the arrow mark is towards the right, so it is plus x. So plus. It is minus, so it is minus. That is minus x. So vertical position, so when you are checking the vertical position, it is plus y axis. So representing plus y axis, so I take it as plus. And when I'm checking the negative y axis, so I take it as minus. So if you get sudden confusion, how to represent the whether it is positive or negative. You can just draw the graph, this particular graph, and make it clarified. So that gives you an gist about how the Cartesian sign convention is utilized. So the diagram keep in your mind. We'll be discussing about the problems in the next section. So here the problem is given. An object is placed at 10 centimeter first condition. Second case at 5 centimeter in front of a concave mirror. The radius of curvature is given as 15 centimeter. We have to find the position, nature and magnification of the image in every case. So there are two cases which has been given to us. Now we are going to solve the first case. So first we have to mention what is given in the problem. First thing is they have given it as the concave mirror. So that is the first case they have given. First is the concave mirror. So I am drawing the concave mirror, shading it to the outer portion. So first center point is the focal length from this 2f. I draw it. Now the center point is the pole of the mirror. Now we are going to see what are the conditions, because they given it as the first condition as u as 10 centimeter. So that is the case. We are going to prove it. So I am just representing everything in the diagram. Now we are going to see how the convention are, because they won't mention whether it is a negative or a positive sign. So you should be very careful in first noting down the sign, because the sign convention will not be given in the problem. So since all the images are formed towards the left hand side, the f, v, u, etc., everything will be negative, because always all the images are formed only opposite to the reflection. That is it. So only to the left hand side it is formed, so it is always negative. Therefore take u as minus 10. Please be careful. The sign convention you have to apply in the problem, they won't give it. So you should be very careful with the Cartesian sign convention. Then only you can use it. Then the radius of curvature is given as 15 centimeter. So centimeter I give it as 15 into 10 power minus 2m. So the focus is f is equal to r by 2. I got it as 7.5. So it is also negative. So please be careful with the sign. You should not mess up with it. Now we are going to, they are asking us three things. First, the position is what? Second one, what would be the nature of the image? And third one, what could be the magnification? So these are the three components which has been given for us to find out. In both the cases, first we will be solving for u as minus 10. Now we know the formula. For the mirrors, the formula is very simple. So I am writing down the formula right now. So it is 1 by f equal to 1 by v plus 1 by u. So 1 by f is equal to 1 by v plus 1 by u. So we have to find out v. Therefore 1 by v is equal to 1 by f minus 1 by u. So just I am marking it up. Now it is simple basic mathematics calculation. So 1 by v equals. Then a sign you should be very careful with. You should not omit the sign. So it is 1 by minus, focal length you have found it as 7.5 minus first we'll take it as minus by 1 by u is minus 10. So now the minus and minus sign will be getting into plus. We will be using it in the next step. Now we are going to take the LCM. So most of them are having difficulties. If you are finding difficulties, just you have to cross multiply and multiply the denominators. That is one of the easiest ways we are going to do it. So if you are still having trouble in finding out the LCM, follow this method. It will be very easy. So cross multiply with the sign, then multiply the denominators. So this time I'm giving the sign thing. So minus 7.5 minus 1 by 7.5 plus that minus and minus converted into plus. So it is plus 1 by 10. Now we are going to take the LCM. So if you're not familiar with LCM, just cross multiply. So it is 7.5 into 10 at the denominator, and in the numerator it is with the sign. So it is 10. So it is minus 10 plus 7.5. So with the sign it is must. So minus 10 plus 7.5, you get it as 2.5. Next I am substituting in the numerator, it is centimeter, so I take it as 10 power minus 2. In the denominator it is 10 power minus 2 and 10 power minus 2. I take it as 10 power minus 4. One thing getting cancelled. So now I multiply it. So it is minus 2.5 by 75. So in order to remove the decimal, once again I am multiplying it by dividing it by 10. So I got it as minus 25 by 750. So when I cancel it out by 25, you will get it as, so that remaining term also 1 by into 1 by 10 power minus 2 will be there. We are not going to convert this particular term, we are going to keep it as it is. So when I am doing this, so minus 25 divided by 750, when you cancel it out, you get it as 1 by 30. So it is minus 1 by 30. So when you will be checking out, it will be always given with the negative sign. So you would have seen U also in negative, V also in negative, and F also in negative. So R also in negative. All the terms, especially in the case of concave mirror, will be negative. So you should not trouble with this particular component. Now we have to find out the remaining cases. So still the problem is not over. We have to find what is the position and what is the nature and what is the magnification. So that is the part we are going to do it next. So I'm going to just make sure we are representing it. So we will be finding out the position, what could be the position, next what could be the nature, and finally what could be the magnification. So to make it simplify, I'm just once again drawing the mirror to show that how the images are formed. So center point is the pole, so U is 10, so I mark U as 10. That is, U are also called as objective distance, V is called as image distance, so don't confuse with it. So U, I take it as minus 10. So just I give you a marking. Then 2F is equal to, that is R is equal to 15 and V is equal to 30. So you will see that the image has been formed beyond 2F. So the image is formed beyond 2F because U is 10. So the image is formed beyond 2F, so it will be an enlarged image. So you should be careful when you are drawing it. It is an enlarged image you will be getting. So now we are going to see about the conditions one by one. So the first one, I'm going to find out what is its position. So you will see that it is a concave mirror. So all the images, especially this is a real one because you are able to capture them in a screen. So it is a real one. So all the images will be formed only towards the left hand side of the mirror. Okay, so it should be very careful with. Now I am going to apply that particular Cartesian sign convention. So be careful, it is a mirror, so no images will be formed beyond it. So if we are getting an image, in the next case we are going to see what will be it. When you are getting an virtual image, what will be the condition? That is the next problem we are going to do with. Now we will be writing out the nature, position, and what could be the M factor. So first one, we are going to find out what is M, that is magnification. So the magnification value m is given by minus v by u. So m is equal to minus v by u. So it is minus 30 by minus 10. So it is minus 30 by minus 10. So getting cancelled, you get it as 3. So it will be 3. Already a negative sign is here, so you're getting it as minus 3. So minus 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 will be getting cancelled. So from this you can tell that it is 3, therefore it is magnified. We are able to capture them in a screen, so it is real. It's a real image, and it is a real image, and as well as it is enlarged. So these are the cases we are going to do. So this is how the first part of the problem is solved. So the image will be magnified, real, and it is inverted. Now I am going for the second case. So the second case is nothing but you have to change u as 5 centimeter. So I change it as 5 centimeter. So u is equal to 5 cm or 5 into 10 power minus 2. There is no change in the radius of curvature and the focal length. So directly apply in the formula. So it is 1 by v is equal to 1 by f minus 1 by u. So 1 by minus 7.5 by 1 by minus 5. So if I follow the same LCM, all the process what I have done in the previous case, I am going to do everything. So it is minus 1 by 7.5 plus 1 by 5. Because minus and minus getting cancelled, it is becoming 1 by 5. Now you have to follow the same LCM method which you have taken. So it is 7.5 into 5 it is. So cross multiply it, minus 5 plus it is 7.5. So minus 5 plus 7.5. So you can see that the value for v is going to be in positive, because you are placing the image between the focal length and the pole. So you will be getting an image which we call it as virtual. So you should be very careful. So it is a virtual image. So that is the reason why you are getting v in positive. So now I am doing it. So when I am simplifying the expression, so it is minus plus 2.5 by the denominator value. So this is having the point, I am removing it. So when I am cancelling it off, you will get it as 1 by 15. It will be in plus. So v is equal to plus 15 centimeter. Always finish it with the unit. So you are getting v as positive. So it is clear that when you are taking it as positive, that means a virtual image is being formed. So you should be very careful with. So a virtual image is formed. Therefore, that is the reason why we are getting as v as plus 15. Now we are going to inculcate this in this particular condition, because we have to find out what is the position, what is the nature, and what could be the magnification. So these are the components we have to find out. So v is plus 15. So it is positive. When you're telling as positive, the first thing you have to get in your mind is it is an virtual image. It is a virtual image, not a real one. That means it can be only seen, it cannot be captured in a screen. It can be seen only inside the mirror. That is the meaning for virtual. So the image will be formed only inside the mirror. You cannot capture them in a screen. So magnification factor I am going to do it. Therefore m is equal to minus of v by u. I substitute as minus of 15 by minus 5. So minus 15 by minus 5. So minus and minus getting cancelled. You get it as plus 3. So then in the previous case we got it as minus 3. So we wrote it as inverted. but here it is plus 3. So the conditions will be, first one, it is 3, therefore magnified. We are getting the answer as plus, so it is virtual. We are getting as plus, so it is virtual. And the last one is, once again it is in plus, so we call it as an erect image. So the condition will be magnified, virtual and erect image. Thank you.